Let me introduce myself first. So my name is Marco. I'm the founder of Mainmatter. This is like officially the Mainmatter headquarter, but we're distributed uh, uh, teams. Was really my office, but coincidentally, most of the team is there because we're having our Mainmatter day tomorrow, and so this is a rare opportunity to meet a lot of our people actually. I want to say a few words about Mainmatter, obviously. Right? So we are a software engineering consultancy. We're focused on web and cloud projects, front end and back end. And we help clients to deliver better results more efficiently, more predictably, faster. And we help them adopt new technologies like Rust as well. Right? So brief overview of our offering. So we do custom development where clients hand over work that they don't want or they can't do themselves. We are doing training and support. We have an extensive catalog of Rust workshops by now. We do team reinforcement, where our experts join our clients' team to help them overcome challenges, for example, around adopting new technologies like Rust. And this often pairs well with training, right? Where we do training first, and then we stay around for a few weeks or months or so to work with them to sort of help the teams that we trained before sort of internalize the things that they learned in the workshop a bit better. And we give strategic advice, for example, around sort of technical transformation, developer infrastructure processes, and similar. And we have a new thing that is specifically for Rust, which is what we call our Rust support subscription. It's a subscription that gives our clients access to our Rust experts for 4,000 euros a month, right? They get dedicated time with our people. They get access to our Slack to sort of answer questions they run into or sort of get unblocked on something. You can check the details on our website, mainmatter.com/rust. There's a bit more marketing. We don't just do all that consulting stuff, but we also organize a conference, which is called Eurorust. I hope all of you have heard about it or have been there before. We're coming to Paris this October after Vienna last year and like a few other cities in the years before. And we do have some stickers over there, some Eurorust stickers, also some Gerust stickers, Mainmatter stickers, and so on. We also, I didn't say that, we also got 30 licenses for Rust Rover from our friends at JetBrains. I think it's just first come, first serve. And we have some of our books over there, and the author himself is also there, Luca. So he can sign them for you later on. Like, again, first come, first serve. Right, and that's the marketing part. So let's switch to content. So you see, overall, we're quite heavily invested in Rust. Right, we believe it's great and has a lot of potential that has not yet fully sort of materialized in a lot of areas. Right, and one of these areas we think is backend web development. So we think Rust is great for that, and areweweb.org agrees Rust is ready for the web. Right? All of the different things you need to be covered sort of in order to be able to write web backends are covered in the Rust ecosystem. There's web frameworks like Exam, Actix, there's database drivers, templating, serialization, deserialization, obviously, tracing, and everything you need, right? But in reality, it is still kind of a draw the rest of the owl situation, right? Like, here's two circles, like figure the rest out yourself. In Rust, it's sort of, here's a set of crates, figure the rest out yourself, right? Ideally, though, sort of we will have something on a higher abstraction level, right? So teams can be focused on sort of on figuring out the essential complexity of their projects and not so much the accidental complexity, right? Which is like folder structure, what goes where, how do I set up logging, tracing, how do I organize data layer, which crates do I even choose for the different things, and so on. There are some approaches, obviously, right? So, I mean, the situation has slightly changed also since I first wrote that slide, which I think was like, I don't know, last summer maybe. There's Loco, there's Rocket, and there's obviously Pavex. They are each a bit different in terms of sort of their approach, and we don't necessarily agree with all of the decisions, although I have to say, obviously, we agree with some or a lot of the decisions, all of the decisions that Pavex makes, and Luca is going to sort of tell you what those decisions are later on, right? But I think Pavex is also sort of a different approach than what I'm going to show you. Is sort of like a completely new approach, with sort of the starting point being sort of more like, let's rethink everything from scratch and try and come up with a better solution, where the sort of underlying sort of idea for Gerust was more, let's look at the sort of existing agreed upon standard crates for the various things and just answer the question, how do we assemble those sort of for a project, right? For a real project. So that is the idea for Gerust, right? It's our idea of how Rust backend projects using those standard crates in the ecosystem should look. And it's based on mainly XAML and SQLX. We could have used Actix, and there's probably no right or wrong answer. There between the two, there's a lot of opinions, obviously, but I mean, that is often the case. I think what might speak for XAML is maybe sort of it's part of the Tokyo project, which I don't know, makes you feel safer about its long-term sustainability and maintenance, maybe. SQLX is easy to use and it's pretty stable, and we specifically decided against using an object relational mapper because, in particular, for the use cases around web backends that we see, Rust sort of being well suited for, we feel like you would rather have a bit more code, but with lower complexity, than have a bit less code or fewer lines of code, right, with an ORM, but then higher accidental complexity overall, and a bunch of new concepts that are not necessarily sort of important for your application, right? But I can show that in practice later what that means for us. One important thing is Gerust is not, despite the name actually, because Gerust means framework in German, right? That's the joke. Gerust is not, despite the name, a framework, right? It's a project generator and sort of project maintenance or sort of development assistant tool in a way, but there's no runtime dependency on Rust, right? Sort of like you create a new project with Gerust, and sort of the project that is created sort of contains all of the code that sort of is needed to run and sort of, or is needed for your application to work. And there's no runtime dependency on Gerust. Like obviously there's runtime dependencies on XAML, SQLX, and so on, right? But sort of you don't have to trust Gerust, right? Which would also be like not a great decision maybe for something that I present here out of the blue, and it's like version 0.0.6 or so. Still, also as a project generator, it sort of answers a bunch of questions sort of that you don't have to worry about then, right? It structures projects into separate crates with sort of separate concerns using workspaces. It establishes a clear folder structure that is sort of is very clear about what kind of thing goes into what file and what directory. Which I think is a very important question, and I think the importance of that question is like easy to I'm missing the word, unterschätzen, underestimate, right? Thanks. And it also comes with generators for sort of creating controllers and entities and so on. While we're not using an ORM, as I mentioned before, we suggest sort of a set of standard patterns for the data layer, which are encoded in the generators again. And Gerust comes with a mechanism for testing and sort of makes sure that every test has its own isolated database, so that you can sort of pre-populate that database with the exact data you need for that test case, right? And it's sort of there's no risk of that interfering with sort of the rest of your tests. So I hope that all sounds good and nice, but words are words, and like we're interested in a demo, I guess, right? Or hopefully. So the idea here is, and I need to switch my arrangement here slightly. Let me just hide a bunch of things. So the idea here is that we're building a note-taking application with a RESTful interface, right? And we're not actually build the note-taking, we'll just build the note-reading, because otherwise this gets too long. And, whoops. So I think that everybody should see my screen in the stream and here, right? Okay. Do I have to make it larger or is it fine? Or let me maybe, yeah, let me see whether I can, because this is also a bit small for me now. Let me change the resolution. How do I change the resolution? 1 second. This is not this. Should be here, right? No.
You have mirror mode, so it takes the resolution from your main.
Wait.
Yeah.
Okay. Great. So we generate a new application. Is this large enough now? Okay. Okay. So I have installed Gerust, right? Like cargo installed Gerust. There's no precompiled binaries, so because you need sort of a running like Rust environment anyway to work on a Gerust application. Gerust Munich nodes, and that creates the application. And then we can look at this. I'm using the Nova editor, if anyone is wondering. It's pretty limited, but yeah. Yeah, like there's a bunch of problems, but I'm used to it. So, right. So you see, here's the generate project, right? And it has Docker Compose with like database setup, so you can easily run that. By the way, I'm going to start Docker because we need that. And it's separated into a bunch of crates, as I mentioned before, using a cargo workspace, right? So we have the CLI crate, and I don't want to go into too much detail, just relatively high level. So that has two binaries, CargoDB, that's used for creating the database and migrating the database, seeding the database, and so on. And the other thing is cargo generate. And by the way, we have sort of a configuration here, so I can run CargoDB versus like all of this, right? And what? Okay, we'll worry about that when we come to it. So that is used for, like I said, for creating the binary, the database and so on. And then we have generate for creating a bunch of things, the blueprints. Like I said, sort of there's no like runtime dependency on the Gerust crate. It's all part of your application. So the blueprints are part of the application as well, right? There are blueprints for controllers and entity test helper. We won't go into detail, middlewares and so on. You would typically not have to worry about this, but sort of when you have your own generators, sort of that would be the place sort of to add them. Then we have the config crate, which mainly has sort of your config struct here, which like server config means like which port do you want to listen on, database config, obviously like database connection string, and so on. Right, and then sort of it can sort of like pass the config from like a set of configuration files and environment variables and so on. Macros, that is Cargo's own test macro, which implements the mechanism for setting up test-specific databases for each test and tearing them down again once the test is complete, as I mentioned before. And then the really interesting stuff is in the DB crate, which contains migrations, obviously, right? But also entities, which is sort of what in Rails and many other frameworks would call models, right? Sort of the structs essentially that represent the data that your application cares about, and then web is the web interface, right? So the web interface has like controllers, middlewares, like routes and application state and so on. And so typically, so for a RESTful interface like the one that we are building now, so if you will have nodes controller with nodes endpoint for reading the nodes, and the nodes controller will use the nodes entity and related functionality from the DB crate to read the nodes from the database and then sort of convert them to JSON and so on. So what we can do now is we can start with creating an entity, because for a node-taking application we need a node entity, obviously, right? And we can run cargo generate entity node. Sorry, it's not Gerust, it's cargo. And I don't know what's up here. I'm not sure what doesn't build when I run the generate binary. Okay, so that works. And by the way, like we just generated the project and we can already run it, but obviously it doesn't do anything. There's no endpoints yet. So let's go back to.
Oh, Rust update. Yeah, Rust update.
What?
Edition 2024. Rust wise, you need to update your Rust.
Rust 2, Rust 2, and it's 2.21.
Shit, I should have tried it. What's it? Rust up, something like this? Huh? Okay. Yeah, but the dependency requires edition 24, right?
Yeah, I mean, you can obviously also just adjust the edition to 2021.
Yeah, but I mean, if the dependency requires the edition, then I would also have to downgrade the dependency and so on, right?
All the version of dependency.
I mean,
What is Gerust?
I don't remember. Let's look at what Gerust is to pass the time. Oh yeah, right. That is inflections, right? So you can sort of like pluralize, singularize, camel case, and so on. Because when I do something like cargo generate entity node, then we want to create a file that's called nodes.rs, but the entity needs to be node singular, uppercase, and so on, right? So we do a bunch of things with a string you're passing. I mean, this is roughly inspired by Rails, but I would say the framework as such is not as inspired by Rails. There's a bunch of things sort of that we take from Rails, but also there's a bunch of things that we don't want to take from Rails. Because, I mean, for example, the sort of Rails default scaffolding, right? Sort of where you have sort of, essentially you have like relatively tight coupling from sort of the database to the view layer, because it's made to be all the same, right? We don't necessarily want to replicate that in Gerust. But we want to, still we want to replicate sort of the simplicity that Rails offers as much as we can. right? Without sort of giving up separation of concerns and so on, right? So I mean, one example for that is, for example, to not use an ORM because it's magic. It's sort of the ORM stuff, the ORM types in particular, in a language like Rust, obviously, leak into sort of all of your application, right? Versus when you're just using sort of like bare Rust structs, sort of, you don't have any additional concepts sort of that leak into your application, right? Sort of additional stuff that is sort of like encoded in the entities that you use everywhere. But you have a bit more code, but maybe that's fine, right? So I think in general you would probably not use Rust for sort of the same use cases you would use Rails for, right? I think I would use, or I recommend Rust to clients for backends when they want to build something where they care a lot about stability. Like Rails obviously is typically not super stable, right? So if you get to a result fast, but then sort of actually making that sort of production ready and stabilizing it is a bunch of work, right? Like with Rust, it's maybe the other way around, right? It takes you a bit longer maybe to get to something which we're trying to address with Gerust, right? And make a bit easier, but still sort of there's a bigger sort of initial step, but then what you get is much more stable, right? It's easier to maintain, and a bunch of other things. Sort of I think for those use cases, sort of you don't necessarily worry too much about the lines of code that you have, right? If the lines of code that you have are like relatively simple and easy to maintain, I think that's better than, as I said before, having fewer lines, but a lot of magic stuff sort of going on, which sort of makes it much harder to reason about the application, really. Right, so hopefully this works now. So we generate an entity, and I forgot we need a field as well, right? So we are saying we create a node entity, and that has a property text of type string. Fingers crossed. Yeah, it's probably going to be fine. Right. So now we have in our database, in our DB crate and entities, we have nodes, right? And node is, like I said, just a struct, right? With an ID field. By default, sort of we're using UIDs, and we're always creating the ID property because it's likely you want to have an ID, right? And then sort of we have the text field of type string. We also generate a change set, sort of from here on, essentially, sort of from line 15 on. Sort of this is where sort of the stuff that Gerust has instead of an ORM starts, right? So the first thing that we create is a change set, right? And sorry, can I make that go away? Let's. I don't like this file panel on the left, and I can't figure out how to put it on the right instead. So that's the main reason, really, why I use Nova. So we generate a change set here, right? And the idea of change sets is actually sort of like taken from or inspired by the Ecto library in Elixir, right? Which also has change set. And sort of the idea is when you create a new entity, you create a change set, and then you pass that to a function. If it validates, if it sort of is like successfully applied to the data store, then you create the then you receive the entity in return, right? And the same for updates, right? You have an entity, you create change set sort of with the updated properties, right? You apply that, and then sort of you get an updated entity in return, right? And this is essentially what we're doing here, right? So if we have a change set that does not have the ID field, because you're not supposed to change that, right? There's a database thing to assign that when sort of the node is first created, but you will be able to change the text property, and you want to have a validation here, right? Here we can say oh, right, yeah, whoops. We want this, right? Because why not? And we also set up we also set this up for fake data, so I can create fake data for my tests easily, right? In this case, yeah, I think we can do sentence, right? This means I can create a sentence between 1 and 10 words, and then later in the test, I can go no change, or I can say no change set fake, right? And sort of I didn't have to do anything to make that work, obviously. Right, then we have like all of the data access and data manipulation functions, right? Instead of an ORM, we just have a bunch of functions. First one is load all, which is sort of, this is like not something that you would typically actually use in an application, right? Unless if you know you're never going to have more than like a small number of records. Sort of this really should have some sort of paging, but that loads all of the loads. Then of the nodes, then loads one node, creates a node based on the change set, as I said, right? It validates the change set. If that is successful, applies the change set to the database, and then and then responds with an entity, right? And update is the same thing, essentially. You pass a change set, apply it if it's valid, and then so if you get a node entity in response, or of course no record found might happen as well, and same for delete, essentially, right? So here you see this is red because we're using SQLX, which does sort of like development time statement validation. I'm not sure what term they are using. So that doesn't work because we don't have a nodes database yet, right? So we don't have a nodes table yet. And I'm just quickly gonna start up the database. So as I showed before, comes ready with a Docker Compose setup with databases like one for development, one for testing. Yeah, this should be fast. And then we can generate a migration, say create nodes. That should work just fine. So you just like timestamped migrations, and so you have ordering built in. I'm going to copy the create table. So from and this is, by the way, the tutorial on Gerust RS, right? Which is essentially a longer version of what I'm showing you. So we can put.
It doesn't generate SQL. Yeah.
No, it doesn't. No. So it's not like Rails in that regard, so that it would generate everything for you, right? It generates a bunch of things, but like I said, we don't want to have that sort of strong coupling throughout the entire application. We could generate some more things. We could probably generate sort of a migration without giving that up, but this is 0.0.6, I think. So it's not really full featured, but it's also, like I said, there's no dependency really, right? This is all your code anyway, so you could still use it and get started, and then sort of like you still benefit from it because you still don't have to do the things that Gerust does for you already, which otherwise you would have had to do yourself. Yeah.
How would you update this if there's like extra features coming out?
We don't know yet. It's going to be hard, probably. Maybe we can build something that makes it easier, but TBD.
Yeah. I guess you roughly have to like parse the code, check which functions are there, which ones changed, and then probably the user.
Yeah. I mean, that's the thing. It gets very, very complex, very, very fast, right? So maybe the answer is just create a new project with a newer version and look at what's different. And I mean, maybe that's a good enough answer, right? So yeah, but yeah, fair point for sure. Very good question. So now we have the migration. We put in the SQL that we need with the database running. So now we can go ahead and create the database. Okay. I probably did that before, so we can migrate the database. No, I didn't do it before, but the database is automatically created because we have configured Docker that way. So now we have created the database. Then this should mean that these red lines should go away. Error communicating with database. Okay. Let's ignore that for now. But we should be able to run this now. Yeah, right. So that means everything is fine, right? But of course, it doesn't do anything because we only created the entity and the migration. So next step is to actually add a controller, right? And add an endpoint. So cargo generate, and we can generate a CRUD controller, which comes with all of the CRUD, like create, read, update, delete endpoints already. So that saves us a bunch of work.
You have different controllers other than CRUD?
I mean, yeah, there's also just controller, which essentially just creates a more or less empty file. Right. So we have the controller. It says do not forget to route the controller's actions in web source routes, because we're also not doing that automatically because it gets arbitrarily complex, right? You have made your own changes to the routes file. We need to sort of route the newly created controller sort of in a non-destructive way. I don't know, maybe keeping the formatting, or maybe the file is currently invalid Rust because you have some changes. Like, shall we write into that? Right? Who can say that? So obviously that's easy on Rails, right? Because sort of you have all of this sort of inflection stuff essentially, right? Which is sort of like simple things at runtime done dynamically, right? Which we can't really do here. So anyway, we have the controller. This comes with all of the functions, right? So I'm gonna delete a bunch of stuff here. So there's an example code in all of those, and like to-dos, right? Telling you, okay, like put this stuff here, sort of change this code according to your needs. But we only care about read all here, right? Because I think have been speaking for quite some time already, and we don't want to. I don't want to listen to me forever. So what this does is sort of, it has sort of debug configured. We add this here as well. But what it does really, it uses the nodes module, the load all function, right? Sort of database pool is coming from the app state, which is also sort of set up automatically when you generate the project. So it's here sort of in like state.rs. Sort of we have the DB pool, which sort of connects a pool based on the database configuration coming from the config crate, and we have a .env file here that sort of contains the configuration that we need, and so on. So this is all sort of the exponential complexity that I mentioned before, right? That you would not necessarily want to deal with, because it easily takes you whatever days or weeks or so, depending on your proficiency with Rust, I guess. Okay, so what this does here, it reads all of the nodes, and we're responding with the nodes JSONified, right? Which is exactly what we need. We need to route this, and we need to, let me remember, this is get, right? No, and then we use create controllers, not greet, but controllers nodes, and then this is and then route get nodes read all. Alright, so if no, what's wrong? Right, yeah. So and so no. Yeah, this is the problem with live coding. Okay, but now it should probably work. No. Is it maybe routing get, right? Yeah. Okay, and then we can so let's right. So no nodes. I'm quickly gonna insert. I know we can also, let's do one thing, because then I can show you one more thing relatively fast. We also have seeds file, which is typically also for like more or less static seed data, right? Like currencies, countries, languages, and so on. But we are just gonna misuse this for creating a node text hello, and then cargo db seed should work. Yeah. So right, and I think that's it. I could show how to write a test, but I'm just going to show the generated test real quick. Sorry, that's here. And we're not going to make that work for now. So let's look at right here. We have a test read all, right? We're using db test. That's Gerust's own macro, and that means we're getting this context passed, and the context allows us to access this test a specific database, right? That's sort of a copy of the main test database that is sort of has a random name essentially, right? That is like automatically generated for the test, and we use that sort of to create a change set for a new node using this fake data mechanism, right? We pass that to the create function that we saw before, and then we know when we read all of the nodes from the database, we get like exactly that one node, right? And then we can have a very specific assertion on the response, right? And that's essentially how tests work. But yeah, it might take a bit of time now to get this working. And now I'm going to switch back to the presentation real quick. I just have 1-2 slides, I think, that I want to show. And I hope that everybody here and in the stream sees everything. Good. Yeah, so that was the demo really quickly, not as quick as I planned, showing how Gerust works, right? What sort of the basic sort of like building blocks and so on are. We have a bunch more stuff built in, like it's set up for tracing. We have support for transactions. We have support for middlewares and so on. So this is sort of more or less ready to go live, right? And sort of you are not doing a bunch of things using this that you would have to do yourself when sort of assembling a set of crates yourself. But there's plans for more. So there's a bunch of things that we don't have. We don't really have a deployment story yet, where you can just sort of, there's something in the README that says to deploy this to production step 1, 2, 3, right? It might not need a lot of code, but I think there's a lot of value in just having something in there, right? Saying like, we recommend this way of deploying, and like I said, step 1, 2, 3, right? You're live. We need to complete the data access layer. There's a bunch of missing things. Like I said, the read all function should not actually be something that anyone should be using, right? You want to have some sort of paging built in. Probably if that can come out of the box, that would be good. There's no concept of relationships between models yet, right? And that gets a bit complex maybe also without an ORM, but there's probably sort of a way that we could recommend or that we could suggest sort of for implementing relationships. And there's no background jobs thing, right? And I think in any real life application, you at some point that is not sort of too far after starting with the application, you will need some sort of background job mechanism. And I think Gerust could have some sort of like suggested or recommended setup, whatever Redis, and then you workers code goes here, whatever, and this is how you run this. And then later, there's a bunch of other things that I think might be interesting. Currently, it just works with Postgres, which I think is awesome and is probably good for 90% of the use case, but I don't know, maybe SQLite or MySQL, whatever, might make sense as well. Maybe some sort of like modern database would also be interesting. Open API integration would be interesting, and automatic upgrades, or at least a documented way or that sort of helps you make that like probably relatively hard and annoying manual work easier. Yeah, but I mean, this is essentially ready to use, right? Sort of, it's just a generator anyway. So if it gets you from sort of step 0 to step 3, might get you to step 7 and 17 later on, but step 3 is already better than 0. So we invite you to use it, give us feedback, and yeah, that's it. Thanks.
Anyone, any question? I have one.
Yeah.
I had a look at the code and see that you are using cargo generate heavily under the hood.
Yeah. Which you contribute to, right? Or
Yeah.
you're the main method. Okay. Yeah.
Yeah. So it bothered me also that mixing Rust code with this liquid syntax is kind of pain in the ass, right? So the IDE doesn't support it, right? And it's super horrible actually. How's your? I mean, since you're using this extensively, how do you deal with it? Are you like always generating it locally using these cargo generate testing options, which automatically does the testing in the background generating so that you can have a watch job on it, or how you?
I did not even know about that. No, I mean, I'm just I mean, I wrote this while learning Rust essentially and learning to build backends in Rust, right? So essentially what I did is I wrote, I think the first thing that I wrote was actually like a note-taking application or so, like a simple use case, right? And sort of answer and sort of like to run into all of these questions that we're answering in Gerust, and then find the answer and sort of like codifying that into Gerust. So what I did, sort of, I wrote the application first, and then sort of like converted it to a blueprint. And sort of, I think the approach for that was really just like regenerate until it works, fixing liquid errors and fixing. I mean, also we want cargo format to sort of not report any formatting violations, sort of, for freshly generated projects. So that meant figuring out a bunch of new line things with liquid, which was very annoying because you're like you're generating something, it works, but there's like one new line too much somewhere, and then you have to figure out, is it like minus there, and then sort of you have no new lines, and it's annoying. But I mean, that was not really the hard part here. So once you know what to generate, it's kind of easy enough to write sort of blueprints or templates that result in the code you want.
But the thing is, I'm wondering about the maintainability, right? Because as you said, right, you have first codified it, and then you transferred this code, this working application, into a template, right?
Yeah.
And then you have to keep it alive somehow, right?
Yeah.
And if, for instance, SQLX has major changes in the API, you probably have to touch a couple of places then. Either you do this in your main application and retransfer to templates, or you do it in the templates and then you lose all the nice, code auto-completion tooling and stuff like this. And it can be pretty annoying, pretty hard to sustain over time. Right?
Yeah, for sure. I mean, we do have relatively extensive CI setup. So essentially, this is probably too small, right? Essentially, what we do is sort of we run the test for Gerust itself and so on, and then we just generate a bunch of applications. So we have different blueprints. You can have a minimal application that doesn't have a database, full application. We have a full example application that has sort of a full CRUD implementation for, I think, tasks and a middleware and so on. So we generate all of these applications and then run them, right, and make sure they work, right? Which is, I mean, it's smoke test, right? But you would typically sort of we should find that anything that goes wrong in terms of major dependency updates or mistakes and in the cargo generate templates, so that all of that will result in some of these things go red. And that seems good enough.
All right.
Cool. Thanks.